What's up, everybody? Welcome back. Patrick here, moving on with polynomial functions. We're now going to be doing a word problem, and this specific word problem is very common. You'll definitely see it coming up in your homework and perhaps coming up on your test as well. So congruent squares are cut from each corner of a 25 centimeter by 20 centimeter sheet of cardboard. The sides fold up to create an open top box. Determine the dimensions of the squares that are cut to create a box with a volume of 798 centimeters cubed. So let's start off by showing what's going on in a diagram visually in this situation. So we have a 25 centimeter by 20 centimeter sheet of cardboard. And then what we're going to do is we're going to cut out squares from each corner. And all four squares are going to have the same dimensions. They are congruent. So we don't know what the dimensions of the squares are, so let's say they just have dimensions x by x by x centimeters. All right, so we're going to cut out these corners. So this won't be there anymore. We can erase those. And then what we're going to do is we're going to take these resulting sides and we're going to fold them. And it's going to create a three-dimensional box. And the box is going to look something like this. So what are the dimensions of the box going to be? Let's start with the height of the box. So what are these sides here going to be? What's their length? Well, if you think about it, if we are folding these sides up and these sides have a length x, that means the height of the box is going to be x as well. And then what about the length and then the width of the box, or the width and the length of the box? Well, if you notice, the base of the box, the bottom side, which I'm going to draw right here, how it relates to this diagram, well, the base is basically this portion here of the box, right? Because these sides get folded up, so the only thing remaining on the bottom of the box is this in purple here. And this purple base corresponds to this purple base here. So what's the dimension going to be of the width of the box here? So this width here corresponds to this length right here. So we need to have an expression for this length here. And notice here how I kept the 25 centimeters and the 20 centimeters, but if you remember, the 20 centimeters represented the width of that whole cardboard sheet before we cut the squares off. And then the length, it was that full length of the cardboard sheet. So notice that from here to here is 20 centimeters. But we don't want that full length. We just want what this dimension is going to be here, the length of this. Well, if you think about it, if this whole thing is 20 centimeters, then this is going to be 20 centimeters minus x minus x, right? So 20 centimeters minus x, because we have this full 20, but we don't need this x portion and this x portion because we only need this measurement here. So this width is going to be 20 minus 2x, right? Because these like terms here, they simplify to 20 minus 2x. So the width of this box is 20 minus 2x. And then similarly for the length of the box, which is this here, corresponds to this length of the base here, this length of the sheet. So from here to here is 25 centimeters. That's the length of the cardboard sheet. But remember, these x's, these lengths x get folded up. So we're just left with this portion here. So this portion can be 25 minus x again, which would be 25 minus 2x. So that's going to be the length of the box. So now we have the dimensions of the box, and notice if you read the question, we're also given the volume of the box. The volume is 798 centimeters cubed. So what we can do now is we can create an expression for this volume, an equation. So we know the volume of a box is what? Length times width times height. Well, the volume of this specific box then is going to be the length, which is 25 minus 2x, so we'll put that in brackets. The width is going to be 20 minus 2x. And then the height is just going to be x here. And then we can make this look nicer by bringing the x in front. And then we'll have 25 minus 2x times 20 minus 2x. So notice now that we have an expression for the volume of this box depending on the dimensions of the squares that are cut out, right? If you remember, x represents the dimensions of those congruent squares. Well, the question says determine the dimensions of the squares, so we're solving for x, that are cut to create a box with a volume of 798 centimeters cubed. So instead of putting a v here, we know that the volume of the box is going to be 798. And now notice how we have a polynomial equation because of this equal sign, and we have one variable to solve for, x. So what we're going to have to do is we're going to have to expand this right side here, bring everything over to one side, and then go through the process of factoring. So writing that equation up here, 798 equals x times 25 minus 2x times 20 minus 2x. First thing you want to do is you want to take these two big brackets and then FOIL them out. So 25 times 20, 25 times negative 2x times 20, negative 2x times negative 2x. Multiply all those out, simplify like terms. You'll end up with this bracket here, 500 minus 90x plus 4x squared. Then the next step is you want to take this x on the outside and distribute it inside the bracket. So x times 500 gives us 500x. X times negative 90x gives us negative 90x squared. And then x times 4x squared, that gives us 4x cubed. And then we have the 798 on the outside here. So again, if you remember solving polynomial equations, what do you want to do? You want to bring everything over to one side. So you're left with a 0 on the other side. So let's take the 798, bring it over to the right side. So we'd be left with a 0 on the left side, nothing left on the left side. And then we would have 500x minus 90x squared plus 4x cubed, and then when this positive 798 goes over, it becomes negative 798. And then notice how this right side is not in the nicest format. We want to have the highest degree to the lowest degree, so if we rearrange it, bring this 4x cubed in front, then comes this negative 90x squared, and then we have this plus 500x, and then we have this minus 798. And now notice how we have a polynomial equation to solve. So what we're going to have to do here is we're going to have to factor that right side using the factor theorem. So for now, let's forget about this polynomial equation that we had left over. And let's deal with this right side here. Let's factor this polynomial. So I'm going to take this polynomial, let it equal f of x. And then what we have to do using factor theorem, we have to try a bunch of different cases. And with word problems like this, usually what's happening is you have to try f of 1, then f of negative 1, etc., etc. Well, because x represents these squares here, the dimensions of squares, dimensions can't be negative. So you don't have to worry or waste time about trying negative numbers. You can just worry about finding positive numbers that work. So f of 1, f of 2, f of 3, you don't have to try out or test out the corresponding negatives. So f of 1, if we plug it in here, that's not going to equal 0. F of 2, if we plug it in, that's not going to equal 0. However, f of 3, if you plug in 3 for the x values, that will be 0. And by the factor theorem, since f of 3 is equal to 0, then we know that x minus 3 is a factor. So what we can do now is we can take this polynomial and divide it by x minus 3. So performing that long division, you can also use synthetic division because this x minus 3 divisor has a degree of 1. I'm going to use long division since I prefer it. So x goes into 4x cubed, 4x squared times, and 4x squared times x gives us 4x cubed, 4x squared times negative 3 gives us negative 12x squared. Subtract these. Negative 90x squared minus negative 12x squared, that's the same thing as negative 90x squared plus 12x squared. These two negatives turn into a positive, and that would give us negative 78x squared. Now let's bring this 500x down. So how many times does x go into negative 78x squared? Well, negative 78x times. So then we got negative 78x squared, and then negative 78x times negative 3, that gives us positive 234x. Subtracting these two here. So the negative 78x squares, those will net out to 0. Then 500x minus 234x, that gives us 266x. Bring this negative 98 down. X goes into 266x 266 times. And then when we multiply 266 by x minus 3, 266 times negative 3 gives us negative 798. So notice how we get a remainder of 0 when we subtract those last two terms. And this should always happen. Makes sense because we said x minus 3 was a factor. And if x minus 3 is a factor of a polynomial, when we divide it, the remainder should always be 0. So if you don't get a remainder of 0 at this step, something went wrong. Either the factor is wrong or the algebra in your long division is wrong. So then, moving on with the polynomial equation, this left side stays as 0, and then the right side, we took this polynomial function and then split it up into two factors, the x minus 3, which was the divisor in the long division before, and then this 4x squared minus 78x plus 266, which was the quotient in the long division that we got before. So now we have to check whether this remaining bracket, this quadratic, is going to factor smoothly, and it actually won't. So from here, we can tell that one of the solutions to this polynomial equation is going to be when x minus 3, when this bracket is equal to 0, that happens at an x value of 3. And then we have to test for values that would make this bracket equal to 0. So this whole 4x squared minus 78x plus 266. And this is a quadratic equation. Even though it doesn't factor smoothly, we can still put in the quadratic formula and see what kind of answers we get. They're not going to be smooth answers, they're going to be decimals, but we still have to check whether those answers can work for this word problem. So we can't factor this smoothly, so what we're going to have to do, we're going to have to use the quadratic formula. So the a value here of this quadratic equation is 4. The b value is negative 78. And then the c value is positive 266. 6. And then when you solve for those x values in the quadratic formula, plugging in the a, b, and c, you end up getting two answers, 4.41 or 15.09 for x. So make sure that you're practicing this quadratic formula because you're going to be using it a lot in this unit. Make sure that you are getting these answers before moving along. So notice for this polynomial equation, there are three potential solutions. X is equal to 3, x equals 4.41, and x equals 15.09. So is the answer that the squares can be either 3 by 3, 4.41 by 4.41, or 15.09 by 15.09? Well, before doing that, we have to see whether these answers are valid. And the way you do that is you take these x values that you got and you plug them in to the expressions for the sides. So notice if we take this 3 here, we'll have 3 centimeters for the height. If we plug in 3 for this expression, we'll have 20 minus 2 times 3, which would be 14, and that's a positive length, which makes sense. And then 25 minus 2x, so 25 minus 2 times 3 would give us 19, and that is a positive dimension as well. So x is equal to 3 is a valid dimension of these squares that are cut out. So that's one solution, 3 centimeters by 3 centimeters. Next, we test out this one, and if we plug in 4.41 for all of the x values, all of the sides will be positive. So we know that this solution is valid as well. So that's another option for the dimensions of the squares that are cut out. 4.41 centimeters by 4.41 centimeters. However, this last x, 15.09, if we plug it in to the expressions for the sides, this height here will be positive. It'll just be 15.09. But when we plug in 15.09 for the x values for the expression for the width and the length, we'll get negative values. And that doesn't make sense. We can't have negative dimensions. So we know this x equals 15.09 is not a valid solution. So the answer to the question, the dimensions of the squares that are cut to create a box with a volume of 798 centimeters cubed, there are two options, 3 centimeters by 3 centimeters or 4.41 centimeters by 4.41 centimeters. So make sure that when you get to this step, you put that resulting quadratic through the quadratic formula. A lot of times students will just stop at this step and say the dimensions of the squares are 3 centimeters by 3 centimeters, but there's also another option. You have to do the quadratic formula if this quadratic doesn't factor smoothly, and then test those x values, making sure that none of the sides are going to be negative, and any that work, like this 4.41, that's also another option for the answer to the question. Another thing that I want to mention is that in this case, the question asks for the dimensions of the squares. So they ask for this x by x here, right? The squares that were cut out. Sometimes they'll ask you for the dimensions of the box though. So what you'll have to do then is you'll have to plug in this x value for all of the expressions for the sides. So if they ask for the dimensions of the box, with this x value of 3, the dimensions would be 3 by 14 by 19. So that would be one answer. And then you would do the same thing, plugging in 4.41 for all of the x values. You would get decimal values here, and that would be another set of dimensions for the box. Also, you can check your answers if they're asking for the dimensions of the box by taking those dimensions, multiplying them out, and making sure you get that volume of 798. Because remember, the box has to have that volume. So if you multiply 3 by 14 by 19, you'll get 798. And if you were to take this x value, plug it into these expressions for the dimensions, then multiply those dimensions out, Because we did a little rounding, you may not get 798 exactly, but it should be very close to 798. But anyway, this is the process. So you create expressions for the length, width, and height. Length times width times height equals the volume. Expand everything, bring it over to one side, becomes a polynomial equation, factor theorem, and then a quadratic equation. And then you get x values, test the x values, making sure none of the sides are negative, and that's how you do the question.